And when we talk about complex numbers, we need to remember that there are two types of numbers in algebra. So what we call our real numbers, which is what most of what we have dealt with, and then there's the complex number. And so the complex number comes about because of square roots. And in particular, we can never take the square root of a non-negative number. So we can never take a square root of a negative number. We can only take square roots of positive numbers. Well, now that means that this forces a restriction on something as x squared equals -1. Because remember, anytime we multiply a positive times a positive, we get back a positive. And when we multiply a negative times a negative, we also get back a positive. So because of this restriction right here, because every time we're doing this, there's no way to get a square, which means you're multiplying a number by itself to get back a negative. So we fix that by creating what we call the imaginary unit. And the imaginary unit are what we call I. And I is equal to the square root of -1. And because of this now, we can do stuff like this and say that a term such as I squared, which is the square root of -1, times the square root of -1 is actually equal to just -1. So the imaginary unit, which we denote by I, is the number where whose square root is -1. That is, I squared is actually equal to -1. So we're going to talk about these things that we call complex numbers. And these numbers are always written in the form A plus BI, where A and B are real numbers. So they're always going to be real numbers, and I is the imaginary unit. The real number part of this expression, A, is called the real part. And the BI is the imaginary part. And when we have it written in this form, it's normally written what we call complex form. So here's how this works. We have a square root of a negative number, which we know can never be a real number. So the way this works is we're going to take out the square root of I. So here, this can be written as the square root of -1 times the square root of 49. Well, the square root of -1 is just I. That's the definition of I. And then we have the square root of 49, which is just plus or minus 7. So we write this as plus or minus 7 square roots of I. Same thing with something like this. Square root of -27, well, you can't take square root of a negative number, so we always factor out the square root of -1 first, or that's just I, times the square root of 27. Well, the square root of 27 can be written as the square root of 9, which is a square, times the square root of 3. The square root of 9 is just plus or minus 3. And you have root 3. And remember, you have this right here, -1, and this right here just equal to I. So what you're left with is plus or minus 3 square roots of 3 I. Generally speaking, we just normally write the I behind the whole number part. So we'll really write this as plus 3 square roots of I root 3. Now, we're going to write these in what we call standard form. All right, standard form is that complex form I said up there. But the standard form, when you have something like this, notice the square root has a negative in it. So we need to take that out. And so we'll write that as 4 minus, this right here can be written as square root of -1 times square root of 36. Square root of 36 is just plus or minus 6, right? And this square root of -1 is what we call I. So we can write this as 4, and we're not going to worry about the plus or minus part here. So we're just going to write this as the real part, which is 4, minus the imaginary part, which is 6I. And it's written in what we call standard form. So up here where I wrote complex form, this should actually be the word standard form. Same thing here, -5 plus the square root of 32, -32. Because of this negative, we need to pull out the I. You're going to write it as square root of 32. Well, the square root of 32, there's a square in 32, and that is 16 times square root of 2. Square root of 16 is 4. So we write this as the real part, which is negative 5, plus 4. And remember, we have this I sitting here. 4I square root of 2. So here's what we do with these particular numbers. We can use regular operations on these particular numbers. In particular, we're going to add and and we're going to add, subtract, multiply, and divide. Now we'll do addition, subtraction, and multiplication in this one video, and then we'll go to division in the next video. So here, or we'll just do adding and subtracting in this one video, and then we'll go to division and multiplication in the next video. So we call the sum of a complex number. When you do this, you add the real to the real. So you're going to add A plus C together, plus, and you're going to add the imaginary BI to DI together. B plus D. And you can, since they both have an I, you can put the I on the out like that. Difference works the same thing, except you're going to do A, and you can distribute this like that. So you get A minus C plus here, BI, or B minus D, and then the I on the outside. So again, all you're doing is you're adding real to real or subtracting real to real, and then you're adding imaginary to imaginary. You put the I on the end. So on this one, 4 minus 7I plus 6 plus 3I. For this, you're going to do 4 plus 6 plus negative 7 plus 3, and you can just put the I on the end. So 4 plus 6 is just 10. Negative 7 plus 3 is negative 4I. Same thing here. 7, and you're doing a minus, so it's 7 minus 2. And I'm going to distribute this out actually and change these signs. So I'm going to make it like this. I like to always add rather than subtracting. So I'll rewrite this as 7 minus 8I plus negative 2 plus 10I. And all I did was I distributed the negative here. I made this negative 2, made that positive 10. So that's why I'm doing 7 minus 2. And because I distributed it, I'm going to make this a positive now, plus negative 8 plus 10, and I on the back. And so when I do this, I get 5 plus 2I.